So what if you could take the brain power of a massive, super expensive AI and just copy-paste its ability to think into a model that's way smaller, way more efficient, and something anyone could use? It sounds a bit like science fiction, right? Well, that's exactly the puzzle we're going to unpack in this explainer.
All right, so here's our game plan. First up, we're going to tackle the billion-dollar question that started this whole thing. Then, we'll get into this really cool teacher-student method. After that, we'll dig into the numbers to see if it actually works. Then, we'll uncover the secret sauce that makes it all possible. And finally, we'll zoom out and talk about what this means for, the future of AI.
Okay, let's dive right in. Section 1, the billion-dollar question. And it really is a huge question. Can you actually copy an AI's ability to reason?
So here's the mystery we're trying to solve. You've got these giant, powerful AI models, right? The ones that can chew through super complex math and logic problems. The real question is, can you teach a much smaller, more nimble AI to do the exact same thing? And, here's the kicker, without putting it through all the same painful, expensive training.
And you might be asking, why is this such a big deal? Well, it all comes down to how these things are built. See, the main way to teach an AI how to reason is through something called reinforcement learning. Think of it like a super complex game of trial and error. And this process, it's a massive bottleneck. It's incredibly heavy on compute, it can be really unstable, and it costs a fortune to run. So if that's the only way, then truly powerful AI reasoning is always going to be stuck in the hands of the few companies that can afford it.
And believe me, people have tried to solve this before. There's this process called distillation, where you try to transfer skills from a big model to a small one. But for reasoning, it just didn't work. The ability to think would get lost in translation. It would just kind of break apart or disappear. For a long time, it felt like an impossible problem. But that's where things start to get interesting.
Which brings us to Section 2, the teacher-student method. This is the super elegant solution that a team at DeepSeek-AI came up with, and honestly, it's a brilliant way to crack this tough nut.
So the beauty of this whole thing is how simple it is. Picture this. On one side, you have the teacher. That's the big, powerful DeepSeek-R1 model that went through all that expensive, painful reinforcement learning. And on the other side, you have the students, a bunch of smaller models. And here's the magic trick. The students don't do any of that hard training. Nope, they just watch the teacher and learn by imitating it. They get to skip the hardest part entirely.
Okay, so how does it work? It's really just 3 simple steps. Step 1, the teacher model solves a bunch of problems, but it doesn't just give the answer. It shows all its work, laying out its entire thought process, step by step. Step 2, all of those detailed examples, the problem, the reasoning, the final answer, get bundled up into a special distillation dataset. And finally, step 3, the student models just study this dataset. They're not solving problems themselves, they're just learning to copy the teacher's thought process. That's it. That's the whole pipeline.
All right, so that's the theory. A really elegant setup, right? But it all leads to the big question in Section 3, proof in the numbers. Does this whole teacher-student thing actually work?
Let's actually look at the data, because this is where it gets really cool. This table lays it all out. It's comparing the original teacher model against its students on some really tough tests. Now, look at the 70 billion parameter student. It gets so close to the teacher's performance, it's amazing. But check this out. Even the tiny 7B and 1.5B models get a huge boost compared to other models their size. The takeaway is clear. The reasoning skill is getting transferred, and it's working at every single scale. And just to really hammer this home, let's zoom in on that 7 billion parameter model. The jump in performance was so big that even the researchers who did the work called it unexpectedly strong. I mean, look at this. The student model, the one that just learned by copying, absolutely demolishes a standard model of the same size. We're not talking about a small improvement here. This is a massive leap in what it can do, and it all came from just watching and learning.
Okay, that brings us to Section 4. We've seen that it works. The numbers don't lie. But now for the really fascinating part. Why does it work? What's the secret ingredient here? What makes a skill as complex as reasoning so easy to teach all of a sudden?
Well, the secret seems to be this idea of an implicit curriculum. Okay, stick with me here. Because the big teacher model was trained with that tough reinforcement learning, it was forced to produce these really long, really structured, logical chains of thought. It couldn't just guess the answer. It had to show its work in painful detail to get the reward. And it turns out that super detailed showing of the work is the perfect lesson plan. It's like a built-in, step-by-step guide for the student models.
And this is the real aha moment. It seems like reasoning has 2 different sides to it. First, you've got strategy discovery. That's the hard part, the creative spark of figuring out how to solve a problem for the first time.
That's what needs the heavy lifting of reinforcement learning. But once a strategy is found, it just becomes a teachable structure. It's a pattern, a recipe. And guess what? AIs are amazing at learning patterns through simple imitation, what we call supervised fine-tuning.
This one quote from the paper just nails it perfectly. RL is required to discover reasoning, but SFT is sufficient to transmit it. Let's break that down. It means you need the expensive, hard stuff, RL, to have that initial eureka moment. But once you've had it, you can share that knowledge, you can transmit it using a method that's way easier, way cheaper, and way more reliable.
So that brings us to our last section, what this all means for AI. And this is important because we're not just talking about a clever little trick here. This could point to a completely new way we think about building and sharing AI.
And the implications here, they are huge. Think about it. This suggests a new division of labor for the whole AI world. The really hard, expensive work of discovery can happen at a few huge labs with the resources to do it. But the distribution of those discoveries, that can be totally decentralized. Suddenly, powerful reasoning isn't locked away anymore. It's accessible. This could mean smaller open-source models can learn the tricks of the giant closed ones. It could literally level the playing field.
Now, of course, we've got to be realistic here. There are some important limitations. For one, a student can't ever get smarter than its teacher. It can only get as good as the lessons it's been taught. This method also works great for things like logic and code, but not so much for, say, creative writing. And maybe the biggest point of all, just because you can copy someone's thought process doesn't mean you actually understand it. There's a big difference there.
And that leaves us with one last big question to chew on. If reasoning, something we think of as the core of intelligence, can just be packaged up and copied like a piece of software, what does that say about what it means to discover something new? What's the real difference between blazing a new trail and just following a map that someone else already made?